This is Looking Forward for Physics 306 for the 17th of February, 2014. As you get ready for class tomorrow, I'd like you to think about the following problem. Imagine that I had myself some sphere, and that sphere was set at some potential v of theta on the surface of the sphere. And I simply want to know, given that potential, v of theta on the sphere, what is the potential inside for r less than capital R? Now, I don't want you to solve it directly, but if you think of the general form, what can we say about the terms, about those a's and b's? Likewise, if I think about the situation where I'm outside the sphere, for r greater than capital R, is there anything I can immediately say about the a's and b's? And if so, does that help us, or how does that help us determine the potential? The second thing I need you to think about is to think about the case of Cartesian coordinates. In that case, we had a Fourier series sum that we needed to look at to match the boundary condition. In our case, we have a sum of some set of a's times r to the L plus some set of b's over r to the L plus 1. And that whole thing times the Legendre polynomial PL. Now, in order to set this sum, we need to either find the a's and the b's. How do we do that? How do we isolate? What trick do we need to use to be able to isolate the individual a or individual b? And what does that require out of our Legendre polynomials? In other words, what property do we hope the Legendre polynomials have that allow us to isolate our a's and b's? And should we expect that indeed should be held or hold for those Legendre polynomials? We'll talk about that and more when we get together on Tuesday. See you then.